Hi guys, so today we are solving quadratics using our factoring method. This is the chapter that we are learning multiple ways on how to solve a quadratic equation. So today we're going back to our factoring method. We kind of learned this in chapter 6. We're just going to expand a little bit more. All right, zero product property. Some of our vocabulary, you're doing section 13.1, page 578, number 1 through 63, every other odd. Okay, so to solve quadratic and other polynomial equations using the factoring method. So a linear equation looks like this. It's 5x minus 10 equals 0. In this case, we try and isolate the x. We get the x all alone. So we do the inverse operation. We do the opposite operation. I add 10 to both sides. And I'm just trying to peel that x away like an onion, get the outer layer first, that 10. Since it's minus 10, I'm doing the opposite, which would be plus 10, the additive inverse. I'm dividing both sides by 5. Since it shows multiplication, we get x equals 2. With a quadratic equation, we don't try and get x alone, but rather, in this case, we're going to factor it, okay? So how would we factor x squared minus 5x? What factor do they have in common? That would be an x. So I'm going to factor out the x, and I'm left with an x minus 5. Now, if factor 1 times factor 2 equals 0, then that means either this factor has to equal 0 or this factor has to equal 0, right? When I have a number times a number and we know that it equals 0, then one of those numbers has to equal 0 in order to get a 0. So what we do is we set both factors. The first factor, x, remember we call this a monomial. There's one term, so monomial, is equal to 0. The second term is called a binomial factor. So we're setting x minus 5 equal to 0. Now it's a binomial, remember, because there's two terms. So I set the x minus 5 equal to 0. And there's nothing really to do with this. But here, how do I get that x alone? I add 5, and x equals 5. Now let's take it back to what we just finished. These are my solutions. Meaning, if x is 0, 0 squared minus 5 times 0 equals 0. That will work. And if it's 5 squared minus 5 times 5, that works, right? 25 minus 25. So both solutions work. Now, what other meaning do those have? The other meaning that those solutions have is that when we go and graph, those x's are our x-intercept. So that would mean that the parabola is crossing at 0 on the x-axis and 1, 2, 3, 4, 5, and at 5. That parabola is crossing at 0 and 5. So when we are doing our zero product property, what we're really finding are our x-intercepts on the graph for plotting that parabola. Okay, let's keep going. So, standard form of an equation is ax squared plus bx plus c, where a, b, and c are integers. So, what we have to do is really get this into standard form as much as we can. Now, I'm going to remind you, a is always in front of the x squared. B is always in front of x to the first power. And c is always a number by itself. Okay, let's try this one. Now, it doesn't look like ax squared plus bx plus c because it's not a trinomial, but it is a quadratic. We see that x squared. So we still have to set it equal. Notice in standard form, it's always equal to 0. So we're going to, what do we do to get it equal to 0? We're going to subtract 36 from both sides. Step 1, set the quadratic in standard form to 0 and use the zero product property. So subtract 36 And then we have 4x squared minus 36 equals 0. Now, can we factor that? Now, let's just talk about, we mentioned standard form. This is our ax squared minus c. There is no b because there's no x to the first power. Okay? But this is standard form because it's set equal to 0. So now we are going to factor. Okay, what's the common factor between the two parts? That would be a 4. So I'm going to factor out a 4. Or I could actually, in this case, let's see what my PowerPoint, I could really divide a 4 from all terms. So I'm going to factor out a 4. I could have, let me go back. I'm going to go back to that and we'll talk about dividing it out. And then I still have another layer to factor, and that's what we call our difference of squares. That x squared minus 9, that factors a perfect square minus a perfect square is equal to, what's the root of x squared? It's an x. What's the root of 9? It's a 3. So it's x plus 3, x minus 3 is the pattern. Okay, so now I'm going to set only my variable terms equal to 0. The x plus 3 equals 0 and the x minus 3 equals 0. Okay, and I get those alone. I add 3 to both, I subtract 3 from both sides. I get x equals negative 3 and x equals positive 3. So my solutions are negative 3 and 3. And again, if that were on the graph, just taking it back to now what you know from graphing, that means it would go through negative 3 and positive 3. The parabola would be going through those parts. All right. Let's pause and see if you can solve these on your own. Pause the recording. Okay, let's see. So we take each factor, x minus 4, x plus 7, set them equal to 0. It's already factored for us. There's nothing for us to do. So now we have to just get those x's alone now. And I'm adding 4. So I get x equals 4. And I subtracted 7 from each side. And I got x equals 7. The next one, I'm setting x equal to 0. And x plus 3 equal to 0. So we know that on the first one, the solution is 0. If I subtract 3 from both sides, I get x equals negative 3. So my solutions are 0 and negative 3. And we put them into the braces for the solution set. Okay? Now, this one's a little bit different in that there are 3 factors. So I'm setting 3x equal to 0, x minus 1 equal to 0, and x plus 4 equal to 0. Okay, divide both sides by 3, x equals 3, add 1, x equals 1, subtract 4, x equals negative 4. So now, if you have 3 factors, that's what we call a cubic function. So I've got 3, 1, and negative 4 are the solutions. And the order doesn't really matter unless you're in function notation form. The last one, we're setting it equal x equal to 0 and 2x minus 5 equal to 0. I've been saying if it's a one step, you don't have to show the work for these. I do want to see you write out the equations, but with the 2-step like this, right, I do want to see you 2x equals 5, divide both sides by 2. And we get x equals 5 over 2, and x equals 0. So 0 and 5 over 2. Now everybody says, do I have to change that? Why? You could make a mistake. Why not just keep it as it is? All right, more of the same. Let's pause and you try it. Okay, let's check our work. For the first one, you should have had negative 2 and 7. For the second one, you should have 0 and 7 over 3. For the third one, you should have 0, negative 1, and negative 2. And for the last one, you should have a 3 and negative 1 over 4. All right, so we have another cubic function. It's to the third power. Those are called cubic functions, but we are going to factor. And if you notice back in the beginning, it said solving quadratic equations and polynomial. So this is a polynomial. It's not a quadratic, it's a polynomial. So what would be my factor, my greatest common factor, and that would be an x that both terms have. So I factor out an x, and I'm left with x squared minus 10. Now, this is what we call our difference of squares. So, how do I factor my difference of squares? I'm going to quickly remind you. What's the root of that? It's an x. What's the root of that? It's 10. When you have a difference sign of two perfect squares, x and 100, one's a plus, one's a minus. Now we set them all equal to 0. X equals 0. X plus 10 equals 0. X minus 10 equals 0. So my solutions are 0. I'm going to say x equals negative 10 here, and x equals positive 10. 0, 10, and negative 10. Maybe I'll put it in nice, neat order. Guess they didn't. Yeah, they did. All right, next one. We have a trinomial. So we have to factor that trinomial. Maybe you're recognizing this by the 25, which is a perfect square, and the x squared. If you don't, then we use our x marks the spot. But this is a perfect square trinomial. I did notice that. What multiplies to 25 and adds to negative 10, that would be negative 5 and negative 5. So this factors to x minus 5 times x minus 5 equals 0. So I really don't have to set this 2 times. There's only one 5. Add 5, add 5. Let's go with the PowerPoint. And there's only one 5 on the number line on the x-axis. So when you are graphing something like this, it's 1, 2, 3, 4, 5. That means it's just touching it. Okay. Over here, what this looks like is like this kind of like this S type of figure. All right. Now, this one gets a little bit different. This one's a little bit different. Got 3 more slides. This one, we have to put it in standard form. That means set it equal to 0. So, if how do I get that equal to 0? Sorry, I put ice on my knee. So I'm going to, what's the opposite of 45n? I'm going to add 45n. And then we've got 5n cubed plus, we're going to put it in standard form where we're going in a descending order. So 5n cubed plus 30n squared plus 45n. Remember, we can't add those together. So now I've got to do a GCF. And so that GCF would be a 5n. All terms have a 5n. And then what I'm left with, when I divide 5n, is an n squared. When I divide 5n, I'm left with a 6n. When I divide this by 5n, I'm left with 9. I still have more factoring to do. That is what we call a perfect square trinomial, in case you didn't recognize it. If you don't, you can always do your x marks the spot. But we get 5n. The root of that, I notice that's a perfect square, is an n. That's a 3. N plus 3, n plus 3. Right? In order for them to both be plus plus. And we can check it by our middle term, multiply, when we add these two, multiply these two, the inner and outer term, we end up with that middle term. I know that this times this equals the 9, and n times n equals n squared. Okay. And so then we're going to set all 3 equal to 0. 5n equals 0, n plus 3 equals 0, n minus 3. My PowerPoint's going quickly, so 5n equals 0. Remember, we're dividing both sides by 5. N plus 3 equals 0. We don't need to do that twice. It's the same thing. There's not 2 places. So subtract 3, n is equal to negative 3. So in this case, we have n equals 0 and negative 3. Okay? We don't need to do that n plus 3 twice. All right, why don't you pause the recording and try the next one on your own. Now let's check our work. 49x, we're going to subtract 49x. And then we have to factor out a GCF of x. And then what we have is a difference of squares. Remember the pattern. It's x. The difference of squares pattern is it's a perfect square minus a perfect square, and when you have that, the root of 4x squared is a 2x. The root of 49 is a 7. One's plus, one's minus. Set them all equal to 0. And we end up equaling 0, negative 7 over 2. If you want to see that work, 2x plus 7 equals 0. Subtract 7. 2x equals negative 7. Divide by 2. X equals 7 over 2. I do want to see you guys do the math for those two. All right. Moving on. All right, so now it's getting more and more complicated. There's just more terms. Remember when we subtract everything equal to 0, we always want to move it so that our x squared is positive. So that means these two terms are going to move to the other side. So the opposite of 7x is negative 7x, and I put that right under its like term. I get x squared minus 4x minus 25 equals 20. And then I'm going to subtract positive 20, the opposite of positive 20. Notice it's just like a constant term. I put it under the constant term. And I get 0. That becomes negative 45, negative 4x, x squared. So what multiplies to 45 and adds to negative 4 is what multiplies to 45 and adds to 4 is negative 9 and positive. Negative 9, positive 5. And so my solution for the first one is negative 5 and positive 9. Okay? All right. Last problem. Okay, before we can mix these up, we cannot move these as in binomial form. We've got to distribute everything. On the left side, I have to distribute the x. On the right side, I have to double distribute. So x times 2x is 2x squared minus 11x. And over here, we're just going to FOIL it. X times x is x squared. Over here, I get minus 6x. Over here, I get plus 2x. And over here, we get negative 12. So when you add those together, it's a negative 4x. The other thing, just reminder, this is a quadratic term, this is a linear term, this is a constant term. Linear means it's to the first power, quadratic means it's to the second power, and the constant term, there is no variable. So when I add those two, you get the middle term's coefficient. When I multiply those two, I get the last term. Now I'm ready to set it equal to 0. Now which way are we going? We're going to go whichever way is going to keep our x squared positive. So since I have 2x squares on the left and 1x squared on the right, I'm going to move everything from the right to the left to keep that x squared positive. So I'm subtracting x squared, right? Then I'm going to subtract the 4x. I'm going to add the 4x since it's minus 4x. I'm adding. And then I'm gonna add 12. Then we factor what multiplies to 12 and adds to -7. How about -4, -3, x minus 4, x minus 3. And so my solution is 3 and 4. And that, my friends, is the lesson. So pause it if you want to keep watching, but have a good day. See you tomorrow.